This video is going to go through the quiz review for Unit 2, Topic 2, Polynomials, our quiz on student learning tasks 13 to 16. The first set of problems give us the directions to simplify the following. And our first problem is f of x plus g of x. So I'm just going to go ahead and write down f of x plus g of x. Because this is addition, I don't need any parentheses. I'm really just going to end up combining like terms. So here we go. The x cubed doesn't have anybody, there's nothing that's alike, so it's just going to be x cubed. Same thing for our 3x squared. Now 4x and 2x, they can combine to make 6x. And -5 and 1 can combine to be -4. All right, number 2, g of x minus f of x. Because this is subtraction, I am going to write this with parentheses. And then minus f of x. I want to make sure I remember to subtract everything. So what I'm going to do, and you're going to see I'm going to do it in red, I'm going to distribute this negative sign. And what I'm going to do is I'm going to make this a plus, and then this is going to become minus 3x squared minus 4x and plus 5. Then when I put the like terms together, 3x squared has no like terms. Negative 3x squared has no like terms. 2x minus 4x becomes negative 2x. And 1 plus 5 becomes 6. Why don't you pause the video at this point and try number 3? Okay, for number 3, f of x minus m of x. And do the same thing I did in number 2 in red. I'm going to change the signs. I'm going to distribute the negative sign. That way I don't forget to subtract the 7. And my final answer is 3x squared plus 7x minus 12. The next set of problems asks me to multiply. So I'm going to write it all out so I can scroll down. I've got f of x times h of x I've got g of x times m of x. I've got h of x. I don't really need parentheses here. Plus m of x. Okay. Ooh, too far. Okay, so now when I distribute, I'm literally just going to distribute to multiply. I'm going to go 2x or 3x squared times x squared becomes 3x to the 4th. 3x squared times -8 becomes -24x squared. 4x times x squared becomes 4x to the 3rd. And 4x times -8 becomes -32x. Finally, if -5 times x squared becomes -5x squared, and -5 times -8 becomes 40. I'm going to put the like terms together. I'm going to go start with my highest power. I only have 3x to the 4th. I have only one x cubed term. I got these 2x squared terms. The 1x term and the constant. There we go. All right, number 5. I'm going to kind of put a little barrier here. Okay, so number 5, I'm going to distribute the x cubed first. So x cubed times -3x squared becomes -3x to the 4th. And x cubed times 7 becomes 7 x cubed. Now I'm going to go 2x times negative 3. X becomes negative 6x squared. And 2x times 7 becomes 14. Okay. Finally, I'm going to do the 1. 1 times 3x is negative 3x. And 1 times 7 is just 7. I'm going to put my like terms together, highest terms first. So nothing goes with the negative 3x to the 4th plus 7x cubed minus 6x squared. Now I have some like terms I need to put together, 11x, and then the plus 7. For number 6, it's just an addition problem. So I'm just going to put my like terms together, and I just have those two constants. So my final answer is going to be x squared minus 3x and then minus 1. The next set of problems asks us to factor completely. Before we get into those, I just want to do a quick reminder of our factoring techniques. Ooh, that was ugly. When we look at our factoring techniques, we always want to remember to start by looking for a greatest common factor. After we've looked for a greatest common factor, we want to ask ourselves, do we have a binomial? Do we have a trinomial? Or do we have a polynomial? Again, this is after looking for our greatest common factor. If it's a binomial, maybe we can use the difference of perfect squares. Or maybe it's the sum or difference of perfect cubes. If it's a trinomial, we need to think to ourselves, is A equal to 1 or is A not equal to 1? If A is equal to 1, that's easy. We just need to figure out what adds to the middle and multiplies to the end. But if A is not equal to 1, we're either going to need to split the middle or we're going to need to use the box method. If it's a polynomial, we want to ask ourselves, do these 4 terms group? And again, at the end, we want to double check any binomials. Are they the difference of perfect squares or perfect cubes? So let's get started. Number 7, again, I'm going to start at the top of my flow chart and look for a greatest common factor. And I see everything here contains an x. If you need to do this, I'm only going to do it on this problem to write this little division step down to help you. And then 5 minus 1, we're left with x to the 4th. Negative 36x divided by x is negative 36. As a reminder, you can always check your factoring by multiplying back. And if I multiply this back, I get x to the 5th minus 36x. What's left in parentheses? This is a binomial. So I'm going to go ahead and look at my binomial options. Is it the difference of perfect squares or is it cubes? It's perfect squares. So I'm going to say x squared minus 6, x squared plus 6. Now I'm going to examine this one that's x squared minus, and is this also now right here, is this perfect squares? It's not. 6 isn't a perfect square number, and that's how I know that this is the final answer. Neither binomial can be factored any further. When I go to look at number 8, again, you have to start. Don't be like, oh, 4 terms it groups. Make sure you start at the top. Is there a greatest common factor? There is. I can divide all 4 of these terms by 2. So that's how I'm going to start. Oop, that should be a 3. Then I'm going to go ahead and group the remaining 4 terms. I'm going to kind of hold on to that 2 for just a second to work with this. So greatest common factor here is going to be x squared. From the second 2 terms in the parentheses, I'm just going to take out a 1. Now my 2 binomials are x squared plus 1, x minus 3, and I'm just going to bring the 2 back down. I'm going to examine my binomials. X minus 3 is, there's nothing to do with that, but x squared plus 1, is that the difference of perfect squares? It's not, so I know my factoring is complete. Number 9, 27 and 8 are not divisible by any common factor. So I'm going to examine this binomial and decide, is it perfect squares or is it perfect cubes? It is perfect cubes. What cubed gives you 27? 3. What cubed gives you 8? 2. Now we're going to square the 3x. 3x times 3x is 3x squared. 3x times 2 is 6x, and 2 times 2 is 4. Then we remember that factoring pattern, SOAP, the same sign, this is positive, the opposite sign, and always positive. 3x minus 2 can't be factored any further, so number 9 is complete. For number 10, again, I always want to start looking for that greatest common factor. And I see that it's definitely X, and I think it's going to be bigger than that. I don't think 8 goes into 1,000. Thinking 2 at first, but then I'm left with 500. So I actually think, no, wait. 8 goes into 1,000. 8 goes into 1,000 125 times. So I'm going to go 8x. And I'm going to have x cubed plus 125. If you've been watching the video straight through, this is a good opportunity to pause it and continue factoring and see how far you can get before you need to check your work. Okay, at this point, what cubed gives you x cubed? What cube gives you 125? X times x, 5 times x, 5 times 5. Same. Opposite, always positive. For number 11, hopefully you took out the 3. And then x to the 4th minus 4 is the difference of perfect squares. And x squared minus 2 doesn't factor any further. Number 12, there's no common factors and there's 4 terms. So I'm going to go straight to grouping. I'm going to take out x squared. And then I'm going to take out minus 9. So then I'm going to have x squared minus 9 times x plus 8. And x squared minus 9, well, hold on. That's not like x squared minus 2. 2 is not a perfect square, but 9 is. So I need to go ahead and factor that. X plus 3, x minus 3, x plus 8. Okay, on the back, we're going to sketch some graphs. It says sketch a graph of f of x and clearly label your roots. So before I get started, I want to notice a couple things here. I want to notice that f of x has a degree of 3 because square the x times this x right here would give me a degree of x squared. So I'm just going to jot that down. The degree is 3. And because there's no negative sign here, it's just a leading coefficient of 1, I have a positive leading coefficient. And what that tells me is that on the right, as x goes to infinity, y goes to infinity. And on the left, as x goes to negative infinity, y goes to negative infinity. It says, what is the multiplicity of each 0? I see I have a double root because I have 2 factors of x plus 3. So negative 3 is a double root. I can either write the word double, or I personally like to just write them out. And then 5, because x plus 5, I only have 1 factor, is a single root. So let's remember the double roots are tangent to the x-axis. So like just touch it, just skim it like a vertex. And 5 is a single root. It just crosses. Okay, so when I sketch my graph, this is nice, negative 3 and 5, I'm gonna have lots of space. 1, 2, 3, 1, 2, 3, 4, 5. Okay, now I want to remember my end behavior is going to look like this and like this. And I can only have a point here and here. I know that I have a double root at negative 3. So I'm going to bring my graph because it starts down here, up -3 and make it tangent at that point. Oh, I missed. And then it just crosses at 5, nothing fancy. Oh, that's ugly. Nothing fancy. Okay, now number 14, I'm going to go about the same way. I'm going to look first at the degree. So this is 2, 3, there's a 1 here, plus 3, the degree is 6. And this negative here is a leading coefficient that is -1. So on the end behavior, even and negative, as x goes to infinity, y goes to -infinity. And as x goes to -infinity, y also goes to -infinity. The multiplicity, now there are 2 factors here that are x minus 4. So I'm going to go 4 and 4. I have 1 factor x plus 1. I have 3 factors x minus 2. So again, degree is 3. I got 6 zeros. It checks out. Let's plan this out now. One, 2, 3, 4. And then -1. Now I have a single root at -1, so that's kind of good. This is a single. 4 is going to be a double, and let's see, I know that it goes down, like, goes down a little bit. I know my end behavior is going to go like this, and I know that this is a double root because 4 and 4. So I'm going to start over here, and I'm going to come up and down and make that tangent root at -4. I know -1 is a single root, so that's just going to, nothing happens there. But over here at 2, this is going to be a little tricky. I have a change in concavity here. Right here, I have to show a change in concavity. It has to come down. So I think the easiest way to do this is to make this like kind of concave up and connect, like it's an up parabola and then a down parabola on this side. Now, if you went the other way, like if you made the right side, let me switch to red. If you had made the right side look like a downward parabola, and then this one looked like an upward parabola, and then you had something wonky going on there. I mean, I'm going to mark it right, but that's probably not what the graph really looks like. Just make sure it's obvious that you have that change in concavity occurring at 2. All right, our last problem, number 15. Well, there's no leading questions. We're just asked to sketch the graph. So let's notice a few things. The degree is 3. The leading coefficient is positive. So we know it goes like this. It's not factored. So take a moment and factor. You should pause the video and factor on your own. So let me see, 3 times -4 is -12. That's going to be -12 and 1. So now this is a 1, so this has to be a 1, and this has to be an x, and this has to be a 3, and a -4. So this is going to be x, 3x plus 1, x minus 4. All right, so now I want to be careful here. I have 3 zeros. I have 0. I have -1/3. And I have 4, and they're all single zeros, which makes the graph easy to draw. I just have to be careful with that -1/3. So I'm gonna go 1, 2, 3, 4, 0. Here's -1, so -1/3 is going to be right next. I'll put it counts like -1/2. That's okay. And I know that this is my end behavior, so it's just going to come straight cuts. 1, 2, 3. Not beautiful, but it works. I hope this video was helpful. Again, anything you had to do with me 100%, you should probably get a clean copy and try it on your own, or at least cover up your answers and try it on your own.